All right, friends, gather around your YouTube screens because I'm going to tell you about ellipses as conic sections. So visually, you probably know what an ellipse is, but we're going to talk about the geometric definition. So an ellipse is the set of all points in a plane where the sum of whose distances from two fixed points is constant. And each fixed point is called a focus. Plural can either be foci or foci. I guess I actually had to look this up because I've heard it pronounced both ways. I guess the American pronunciation is typically foci and the British pronunciation is foci. So there's just different ways cultures have taken this word from its Latin base. So anyways, so that's the plural. I'll be using foci. So you have two foci for the ellipse. So the easiest way to visualize the construction of this concept of distances, this sum of distances, the way that kind of works out is, okay, so let's say that I have two nails. So let's pretend that I'm looking from the top down and that these are two nails. So imagine if I were to take a string. So a string, if you were to wrap it around these two nails like this, so what the string's going to do is it's actually going to maintain the distances. If you pull that string as taut as possible, you can put a point here. And these two distances will end up being the same as you go around this ellipse. So maybe I go here and then I plot another point over here. So you can kind of imagine tracing out the ellipse using these two nails and a piece of string. And so the shape that you would get would look something like this. And so the string will maintain the maximum amount of distance kind of in this situation. That's a way to think about it. Okay, so there's a lot of pieces about the ellipse, and I want to just jump straight into the equations for this. So we have two different types of ellipses. You can have one which has a major axis running along the x-axis or parallel to the x-axis. So I said on the x-axis, but really it could be parallel to the x-axis. So here's what the equation looks like. X minus a squared over a squared plus y minus k squared over b squared equals 1. Okay, so the fact that this equals 1 and this being divided by two numbers, that's kind of important for the format. As far as the h and the k go, so that's what's going to describe the center. So here's my hk, boom. And so the a and the b in this equation are pretty important. So I'm going to show you kind of this theoretical version of the equation, but I think once we get into the examples, the setup of this is going to make way more sense. So your a, when you have the two numbers in the bottom, the a is always the largest of the two numbers. So I'll show you how this will change if it were below the y in a second. And so the vertices can be found by taking h plus or minus, let's see, maybe actually I can go along this. So this a is actually describing a distance. So this is a squared if you take the square root of this number. So this a will go out this way, and that will get you a vertex, which will be h plus or minus k. And then this b is describing the minor axis. So you can think of these two numbers here as giving you a distance coming out from the center. I'll show you how that works with a more concrete example in a second. And basically, once you know these distances, by using the graph, you can figure out what the other points are. So understanding the construction of this and then just having the visual in front of you is really what's key. I have the memory of a hamster. I can't remember all of this stuff, but I can remember how the construction works. So I'm just trying to point out some of the key things to you. The last thing that you want to know about this are this concept of the foci or the foci. Okay, so the foci always run along your major axis. So whichever way your parabola or your ellipse runs, the foci lie on the longer side. So the foci are found by this equation h equals plus or minus c, where c is calculated this way: c squared equals a squared minus b squared. So this would be how I could figure out the foci. So like I said, if you just try to memorize all of this, this is like a nightmare to memorize. The key with conic sections is understanding like how to read these equations and knowing like key things like how to get to C. And that's really what's going to make the difference in how you graph these and understand these. If you try to just memorize everything, it's going to get really tough. Okay, so let's change our perspective here and think about the other way the ellipse could look. So the major axis either running parallel or on the y-axis. So here's my major axis, here's my minor axis in this case. So look at how this equation looks. This looks almost the exact same, but notice that my a squared now is under the y and my b squared is under the x. So these equations look like you can't necessarily tell the difference between these equations just by looking at them. The key is, where is the larger number underneath the x and the y? And similar to this, so as far as like how you figure out your vertices and your foci, so your A is going to dictate, so when the A is under the Y, so that's talking about distances from the center. Here's your center, HK. Here's the distance to go in each direction in the Y direction. And here's the B distance to go in each direction for the X direction. So we'll make sense of that in a moment. And so from that, you can just calculate from the graph what all these other coordinates should be. And you'll have your foci now lying on this major axis. And so again, you just do that same calculation for C to figure out what the foci are going to be. So the key things are kind of knowing this structure of the equation. So the A and the B, whichever number comes underneath, is going to be what determines what your major axis is. The rest of these is in terms of like vertices and foci, like you can figure that on the graph, but you really need to know this equation, and then you really need to know how to calculate your C. So it's really important that A is the major axis. Like whatever the larger number is under your X and your Y, that's where your major axis is. And so when you're doing this calculation of C squared equals A squared minus B squared, this should always end up positive. If it doesn't come out positive, then you flipped something and did it wrong. Okay, so now we can go into some exercises. So we're going to graph each ellipse. We're going to give the domain, range, center, vertices, endpoints of the minor axis, and focus. So basically, we're just going to like take all that information I was just showing you and we're going to apply it. Okay, so when I look at this equation, so a couple of things I want to figure out right away. First, my center. Well, there's no like plus or minus number next to the next to the X or the Y. So the center in this case is just going to be 0, 0, okay? Now, the larger number in this case falls underneath the Y. So the major axis is on the Y axis. Okay. So my A in this case, you've always got an A and a B under these two things, all right? The A, when you take the square root, is the larger of these two numbers. So this is the larger number, so if I take the square root of this tells me right away my A is equal to 5, and then my B, if I take the square root of 9 is equal to 3. So now I've got my A and I've got my B. So I can do a lot of calculations with this. The last thing that I really need to know before I start graphing and figuring out all the other information I was asked is what is my C? So my C squared is going to equal 25 minus 9, which equals 16. So what does that say about C? That means that my C is equal to 4. Okay, so now we can graph this. So let's bring up some graphing paper. Okay, so the first thing that you want to do with an ellipse is you want to graph the center. So my center was right here at 0, 0. And now that you know your A and your B, this is the directions that you want to count out. So the way I look at this, in the Y direction, I need to count out 5. So I'm going to go 1, 2, 3, 4, 5, up, 1, 2, 3, 4, 5, down. And then in the B direction, I'm going to count 3 in each direction. 1, 2, 3, 1, 2, 3. And now for the worst part of having to ever show anybody how to do this. Now I have to connect all the points, and we'll see how my ellipse looks. It's probably going to look terrible because I'm like terrible at drawing under the gun. It's not the worst ellipse I've ever drawn. Okay, so here's my ellipse. So I just connect those 4 points. Now, from this, I can get a lot of information. We've got the center. We can tell now the domain and range. So my domain, so my x values just go from here to here. So that's going to be from -3 to 3. And for my range, that's going to go from here to here. So lowest to highest, so that's -5 to 5. And it includes the points, so it gets a square bracket. Okay, so for my vertices, so the vertices are the endpoints of the major axis. So here's my major axis in this case. So this is one vertex and this is the other vertex. So for my vertices, like I said, once you draw your graph, it's like pretty easy to figure it out because you can just read it off. So the vertices in this case are going to be 0, 5 and 0, -5. We were also asked for the endpoints of the minor axis. So that's this line here. So these points here are the endpoints of my minor axis. So I'll just say minor axis. And again, I can just read those off. That's 3, 0 and -3, 0. So now we've answered quite a few of the questions. The last question is what's the focus or the foci, I guess is really what's proper. And so that's where our C is going to come in. So my C is equal to 4. So I'm going to do the same thing. I'm going to start here at the center and then I'm going to count out 1, 2, 3, 4. So let's see. I haven't used the white color, so I guess I'll just use that. 1, 2, 3, 4. Here, 1, 2, 3, 4. And here. Okay, so there are my foci. So that's going to be at 0, 4 and 0, -4. Now I have all the information that I was asked. Okay, so let's try another one. So I've got 9x squared plus y squared equals 81. So notice this is actually not in the desired format. So I wanted to just kind of throw a curveball. So you need this to be equal to 1. So the easiest way to do that then is to divide everything by 81. So divide by whatever you need to turn this into a 1. And this should be 81, sorry. Okay, so now I can rewrite this equation as x squared over 9 plus y squared over 81 equals 1. So there's my new equation. Okay, so once again, the center here is at 0, 0. And I'm actually going to slide this equation into this top spot. And now you've seen me do one example. So you can tell just by looking at this that the major axis is once again going to run along the y-axis. So why don't you pause the video here and give this one a try to find all the information, and then hit play. So you can refer to your last notes and just see where you're getting stuck, and then hit play when you're ready. Okay, so I can tell just by looking at this, my a is so this is my a squared because it's the bigger number. So my a is equal to 9, so my b will be equal to 3. And my c is going to be 81 minus 9, so that's 72. Oops, that's my c squared. So my c is going to equal the square root of 72, and approximately that is, this is like 8.49. Okay, so now I can set up my graph paper and we can start sketching some things. So here's my center at 0, 0. So I'm going to go out 1, 2, 3, 4, 5, 6, 7, 8, 9 in each direction on the y-axis, and then out 3 in each direction on the x-axis. Cool. So then I can connect those points, and this is just going to be all messed up because my scale's like not, I don't have this drawn to scale. But okay, so now I've got the pieces there, and I can really start with this problem, right? So my domain is going to go from -3 to 3. My range is going to go from -9 to 9. My vertices, so just to save space, I'll write this as 0 plus or minus 9. You know that those are 2 points. And then my minor axis endpoints are going to be plus or minus 3, 0. So vertices are these points here. Minor axis endpoints are these points here. So we've got almost everything that we need now. So now we just need to get to the foci. And so for that, now I just kind of have to approximate a point here. So 8.49. So just like somewhere between 8 and 9, right? So I'll just kind of draw those there. So for my foci, that's going to be 0 plus or minus this 8.49, or square root of 72 to be more exact. I should really write square root of 72. Okay, so there's all the information for that one. Okay, so I've got one more now. So now we're going to change it up and we're going to have a different center. So for this one, what is the center? The center is going to be 1, -2. So really the rest of this process works the same. I personally think you can do this. So I want to challenge you to pause here. Try to get all the information from this one. If you didn't get it right the last time, this is a great time to challenge yourself. You can tell that the major axis now runs like parallel to the x-axis. So give it a go. Try it out and then hit play when you're ready. All right, so let's see. My A in this case is found here. And so that's going to be 3, and my B is going to equal 2. My C squared is going to be 9 minus 4, which equals 5. So my C is going to be equal to the square root of 5. So we can just approximate that again. Okay, so I need some graphing paper. So first things first, I'm going to plot the center point. And like I said, this all really works the same. So in this case, so going in the x direction now, I'm going to count out 3 because the bigger number now is under the x's. So I'm going to count out 1, 2, 3 this way, 1, 2, 3 this way. So you can see that having the graph is very, very helpful now. And then going for the minor axis, so I'm going to go 2 in the y direction. So it's going to be 1, 2 this way and 1, 2 this way. Okay, so I can connect everything. And so now I can read a lot of these points off, right? So for my vertices, so my vertices are the ends of the major axis, the ends of the major axis. So let's see, this is going to be, this looks like 1, 2, 3, 4. So this is 4 and -2. And then the other point is -2, -2. For my minor axis endpoints, so that's looking like 1, 0 and 1, -4. My domain, I should have started with that, sorry. My domain goes from -2 to 4. Oops, 4. And my range goes from -4 to 0. And then finally, I've got to get my foci. So those are going to fall somewhere in here. And then you can just figure out like what's happening kind of with the math here. So for my foci, so then for this one, so I'm just moving the x-coordinate. So I'm starting at the center. So the center was 1. And then I can add the square root of 5. And I can also subtract the square root of 5. So 1 minus the square root of 5. And that's the only way that that can really work. So you don't need an exact number necessarily. You just need to know like, okay, I'm moving in the x direction, so I need to mess with the x coordinate. So once again, so this video is getting just a little long, so I think I'm going to cut it off here. So we still have to talk about equations of ellipses. So I'll talk to you about that in the next video. I'll catch you guys there.